to now do a review for Chapter 5. So the first topic I want to review is just a few of the basic exponent rules. So the difference here between multiplication, a power to a power, and division, or the quotient rule. So in the first example, second example, and the third example, notice the bases are the same. They're all w's, the base. So on the first example, we have w to the third times w to the fifth, and that is w to the eighth. That is an example of where you add the exponents. And you add the exponents because when you think about it logically, what w to the third means, and when you think about it, what w to the fifth means, if you were to write it all out, it's all multiplication. Therefore, you're multiplying w times itself 8 times. So for the second example, you have a power to a power. So notice w is only written once. So this one is w to the 15th. Here is where I actually multiply the exponents. And if you think about this one, w to the third to the fifth would mean w to the third times w to the third times w to the third, so on and so forth. You would write that 5 times. And if you were to do that and write it all out long ways, you'd have w to the 15th. So the third one, this is the quotient rule. And now the quotient rule, it does say subtract the exponents. So if I do w to the 3 minus 5, that gives me w to the negative 2. And now we're left with the negative exponent, which is not simplified. So to simplify a negative exponent, I need to first think about this as a fraction, so I can put it over 1. And you are not supposed to have a negative exponent in your answer. So that means you either move the base up or down, depending on where it started. So here it's in the numerator, so I need to move it to the denominator and make it positive 2. So I have to write something in the numerator. I can't just leave it. This is not w squared. This is 1 over w squared. So on this last example, this is not actually the way that I think about this. So you get 1 over w squared, but an easier way to think about this for myself is I think about this w multiplied by itself 3 times, w times w times w. The denominator would be w times itself 5 times. So if I were to think about reducing this and simplifying it a little at a time, since it's all multiplication, I'm allowed to say, okay, w over w is 1. W over w is 1. W over w is just 1, so it would cancel. So I can actually just kind of think about it mentally, that you would have w times w in the denominator. So there you go. So for more exponent rules, we have that 0 exponent property, and that says that anything to the 0 power is 1. And so since 5 is to the 0, it's 1. And in the second example, because of these parentheses, that means everything in parentheses is to the 0 power. So this is also 1. Now on this third example, you have to be careful because 5 is not to the 0 power here. 5 has an exponent. 5 is to the first power here. 5 is to the 0 power. X is to the 0 power. But here, this is 5 times x to the 0, which is 5 times 1, which is 5. So now looking at just a couple examples where you combine some of the exponent rules. So here, I have multiplication. So I have negative 6 times x times negative 3 times x times x times x times x. So I could write it out if I wanted. But remember, multiplication has that commutative property that says I can change the order I multiply in. So since everything here is multiplication, I can think about this as negative 6 times negative 3, then times x squared, then times x to the 4th. And again, this might be something I do mentally that I don't actually write out. But when you think about it that way, I can see, okay, negative 6 times negative 3 makes positive 18. X squared times x to the 4th is x to the 6th. And I am done. That one is complete. So here we have another example. So because everything is in parentheses and everything in parentheses is being multiplied, I would essentially, it's not quite the right word, but distribute that exponent to everything in there. So it's called the power of a product rule. So everything in parentheses will get that -2 exponent. So that gives me 3 to the -2 times x to the -2 times y to the -2. So when I have negative exponents, that right off the bat tells me my problem is not simplified. So I'm going to make this a fraction, and then I'm going to look through and I'm going to move everything that has a negative exponent. So 3 to the -2 has a negative exponent, so I need to make that 3 to the +2 by moving it in the denominator. X to the -2, I need to move that, make it x to the +2. Y to the -2, I need to move that as well. So it's really important that you put a 1 in the numerator so that it's clear all of these are in the denominator. So the only thing I could change here is I could make 3 squared. I could make that a 9. And that is complete. So something off to the side I just want to point out and remind you about. 3 to the -2. So these in every math course cause a lot of problems because people are so tempted. I think just naturally your brain wants to say, oh, that's negative. But a negative exponent is not going to make something negative. So that 3 to the -2 does not mean -6. It doesn't mean -9. It means I need to move the base. So since it's currently in the numerator, it needs to move to the denominator so that I can make the exponent positive. So 3 to the -2 is just 1/9. It's not negative. So if I were to think of something like this, though, like maybe -2 to the -3. So since my base is negative, maybe my outcome is negative. So the first thing I'm going to do is I'm going to make that over 1, make it a fraction since it's not already. I am not supposed to have a negative exponent. And so I am going to take that -2 and make my exponent positive. And I need to put a 1 in the numerator to make sure that it's clear this is in the denominator. Now here, -2 to the 3rd will be negative because that is -2 times -2 times -2, which is -8. So I end up with -1/8. So a negative exponent does not mean you're going to have a negative outcome. Sometimes you will, sometimes you won't. It depends on the base. So for a last exponent rule example here, when I'm faced with problems like this that have multiple things going on, I always recommend just doing one little step at once. So doing it in several steps instead of all at once. So first I will look at 4 and 12. So 4 over 12 is not 3, it is 1/3. So 4 over 12 is 1/3. And then I'm going to go through and look at all the variables, and I'm going to rewrite everything. So w to the -3 needs to move, so I can write that exponent positive. Y to the 3rd will stay in the numerator, so now I need to rewrite it. So right now I've taken care of this, I've taken care of this. Now I need to look down here. W to the -2 has a negative exponent in the denominator, so I need to move it to the numerator, to the top here. And lastly, y squared is perfectly fine. You have a positive exponent. So I'm going to rewrite that in the denominator, but I'm not going to change anything. So now that I've rewritten it, I can start simplifying a little more. So I'm going to rewrite the 1/3. w squared over w to the third, instead of just like subtracting the exponents and getting a -1 and thinking about moving it, what I'm going to do is think about if that's w times w, that is w times w times w, I would be left with just w in the denominator. So now I've simplified those. Same idea for the y's. Y to the third over y to the second would be y to the 1. And that problem is complete. So another topic that will show up on the Chapter 5 test is scientific notation. So these two numbers here are both written in what's called standard form. So if you're asked for standard form is this. It's the way that numbers are typically written, standard form. Scientific notation is where you rewrite the number with just one number in front of the decimal. So I would write this as 4.57. And I would write this number here as 1.23. So you can only have one number in front of the decimal. And then you multiply by a power of 10. So that's just how scientific notation goes. There can only be one number in front of the decimal, and you write it times 10 to the, and that's what we're going to look at now. So I count how many times I had to move the decimal. So I moved this decimal 1, 2, 3, 4, 5 times. And I moved the decimal 5 times to the right. I made this number bigger. So that's going to be times 10 to the -5th. And this last one, the decimal, there was an understood decimal here at the end of that number. So I had to move this 1, 2, 3, 4, 5, 6, 7, 8 times. So that would be times 10 to the 8th. So when you have those positive exponents versus those negative exponents, that determines whether you're going to make a number bigger or smaller. And then the last topic I wanted to look at before the Chapter 5 test is adding, subtracting, and multiplying polynomials. So here you'll see I have the same two binomials in all three of these examples. So in example 1 and 2, since I am adding and subtracting, the exponents will not change. So what I mean by that is I have an x squared and an x to the first power. Therefore, in my answer, I should not be getting anything other than an x squared or an x to the first. No x cubed or to the fourth or anything like that. So for the first one, when I'm adding, I'm really just combining like terms. So since there's nothing to distribute here, nothing to distribute here, the parentheses really aren't even necessary in this example. So I could actually just get rid of them. I don't really need them. And these two binomials could be written vertically. Okay. So now whenever I go to add these, I'm just combining like terms. So I'm going to start with the x squared terms. 3x squared plus 5x squared. So that would give me 8x squared. I do not change the exponent. I'm just combining the like terms to get 8x squared. And here I have plus 1x. Remember, you have an understood 1 here and here. Minus 7x. So I have 1x minus 7x, which would give me minus 6x. And that is your answer. And so notice I'm writing it in standard form. Remember, standard form is when you have the highest exponent first. So I did the x squared term before I did the x to the 1. So in the second example here, that first set of parentheses, that 3x squared plus x, nothing is going to change about that because there's nothing to distribute out front. But on this second group here, I'm subtracting everything in parentheses. So it's kind of like I'm distributing a -1. So that's going to become minus 5x squared. And then -1 times -7x makes that plus 7x. So that is not quite my answer yet. Now I need to combine like terms. So I'll start with my x squared terms. 3x squared minus 5x squared will give me negative 2x squared. And then I have my 1x, again with the understood 1. 1x plus 7x gives me plus 8x. And there's my answer, and it's in standard form. Now on the third example, I am multiplying. So when you multiply, the exponents will change. So here I'm going to use that FOIL acronym, F-O-I-L, for first, outer, inner, last. It actually does not matter if you multiply in this order, as long as both of these terms get multiplied by both of these terms. But the FOIL just helps remember not to leave anything out. So I will do the first term here times the first term here. So it's really just like those previous examples we were just doing. I'm doing 3x squared times 5x squared, which was the exponent rules we were just looking at. So 3x squared times 5x squared gives me 15x to the fourth. Now my exponents are changing. Now I'm going to do the outer in each. So the outer term times the outer term here. That gives me minus 21x cubed. And now I'm going to look at the inner terms, the two inside terms. So remember that's x to the 1. So I get x times 5x squared. So that would give me plus, they're both positive, 5x cubed. And now the L for last, I'll multiply the last term in each binomial. So I get x times negative 7x, which gives me negative 7x squared. So now I've done all my multiplication. I multiplied 4 times. So now I need to combine like terms. So from here, my exponents won't be changing anymore. Here I'm just combining like terms. So I have 15x to the 4th. Nothing here to combine that with. But then I have negative 21x cubed plus 5x cubed. So that gives me minus 16x cubed. Just combining the coefficients. And then last, that negative 7x squared has nothing to combine with. And that is your answer. So you have a trinomial, 3 terms here. And so the last thing I want to remind you about is the difference between this 2x squared and this 2 plus x squared. So if you're taking any other math classes, this will continually come up. So the difference in these two is this is a monomial. This is one term. This is a product. So whenever you have a product like this, you can give that exponent to everything in parentheses. So that would be 2 squared. That would be x squared. So you end up with 4x squared. But here in this second example, I'll clean that up a bit, you cannot distribute that 2. This is a binomial. This plus sign here means these are 2 different terms. So this is not 2 squared plus x squared. A lot of people do that, and it is not correct. So if you are asked to square this binomial, 2 plus x squared, that means you have to take the whole binomial 2 plus x times the whole binomial 2 plus x, and then that's where you would do the FOIL method. Okay, so I hope that helped. Happy studying, everyone.